This is a video demonstration for the volume rendering project by Anthony Cummings for CS 6630 Fall 2009. As we open the volume rendering application, we are presented with two windows. One window showing a blank transfer function, a second showing our volume. Currently we see only a color cube, which is used by the GPU to generate ray directions through the volume for the shader. The program allows for a user to easily open a raw volume dataset. After opening a volume file, we can zoom and rotate to examine the loaded volume. This dataset is taken from volviz.org and represents the head from the Visible Human project. The volume is currently rendered using a simple mapping of density to alpha values. Overlaid on the transfer function window is a 2D histogram of the values found inside the volume, where the abscissa and ordinates are the density and magnitude of the gradient of change found within the volume. This histogram presents cues to users that will help in the design of transfer functions to show the desired surfaces and materials. The dynamic transfer function interface allows the user to create simple colored boxes to generate transfer functions for the volume. This implementation for creating transfer functions is quite limited. However, this limitation makes it very easy to use. Here we will create a transfer function to show the skull under a translucent skin. This current transfer function is equivalent to a one-dimensional transfer function with color and alpha values for specific densities found within the volume. Now we will reset the transfer function and build a new two-dimensional transfer function that will highlight the renderer's abilities to show materials of similar densities with different colors. Utilizing the cues provided by the 2D volume histogram, we can determine where the most prevalent gradient changes occur within a volume at a particular density. This visual cue defines a boundary between materials of similar density. Notice how the material near the forehead is now drawn in a bright red color. This ability to draw multiple materials with similar density values is made possible by adding the second dimension to the transfer function. Using the magnitude of the gradient of the density of the material as the second dimension in the transfer function allows the renderer to detect and draw the boundaries of these different materials. Finally, the application has the ability to save snapshots of both the volume and the current transfer function for later use or print. This concludes the brief video demonstration of my volume rendering project.